Assalamualaikum and hi. So our group will be presenting on our group project entitled the High Performance Liquid Chromatography in Health. Our group members consist of me, Sharifah Lala Lydia binti Wan Tarmizi, Rachel Anak Bakir, Nurul Arifah binti Razani, and Ashra Nurbaya binti Abdullah.
So, what is HPLC? HPLC is a physical separation technique conducted in the liquid phase in which a sample is separated into its constituent components by distributing between the mobile phase, which is the liquid, and a stationary phase.
For the first application of HPLC, HPLC is used in medicine for the determination of therapeutic drug levels. For the introduction, HPLC is best known for its use with pharmaceuticals. The technique is used to analyze drugs and medicine for their purity to maintain the highest standards for pharmaceutical products, with the end goal of helping patients with medical issues. As for the objective, the aim of this study is to identify and quantify loratadine and its active metabolite in human plasma by high-performance liquid chromatography with mass spectrometry detection. For the methodology, loratadine and disloratadine in plasma were studied by HPLC methods with UV or fluorescence detection with a sufficient lower limit of quantification for the purpose of the study. By applying liquid-liquid or solid phase extraction, HPLC with MS detection was extensively used in the past year for the sensitive quantification of loratadine and disloratadine, with a very low limit of quantification obtained, mainly after liquid-liquid extraction of analyte. After addition of the internal standard metoclopramide, the human plasma samples 0.3 ml were precipitated using acetonitril 0.75 ml, and the centrifuge supernatants were partially evaporated under nitrogen at 37 degrees Celsius at approximately 0.3 ml volume. The loratadine, disloratadine, and internal standard were separated on a reverse phase column under isocratic conditions using a mobile phase of a mixture of acetonitril and 0.4% formic acid in water. The flow rate was 1 ml per minute and the column temperature of 45 degrees Celsius. The detection of loratadine, disloratadine, and internal standard was in MRM mode using an ion trap mass spectrometer with electrospray positive ionization. Calibration curves were generated over the range of 0.52 to 52.3 nanograms per ml for both loratadine and disloratadine, with values for coefficient of determination greater than 0.994 by using a weight quadratic regression. The lower limits of quantifications were established at 0.52 nanograms per ml, loratadine and disloratadine, respectively, with an accuracy and precision less than 20%. Both analytes demonstrated a good short-term, long-term, post-preparative, and freeze-thaw stability. Besides its simplicity, the sample treatment allows obtaining a very good recovery for both analyses around 100%. For the results, taking into account these facts, the aim of the present study was to develop a fast HPLC method able to quantify loratadine and disloratadine in human plasma after oral administration of a therapeutic dose of loratadine after a simple step of extraction. Finally, the developed and validated method was applied for bioequivalence investigation of two medicinal products containing 10 mg loratadine. For the conclusion, the proposed method provides accuracy and precision for quantitative determination of loratadine and disloratadine in human plasma after oral administration of 40 mg loratadine. The simple sample preparation by protein precipitation and selected signals for monitoring allowed a specific and efficient analysis of a large number of plasma samples, making the method more productive and thus more cost-effective.
Number 2 is HPLC used in quantification and identification of polysaccharide contents in Hericium erinaceus, also known as lion's mane. The aim of this study is to identify and quantify sugar and polysaccharide contents in locally grown Hericium erinaceus. Why are polysaccharides important? This is because polysaccharides' main functions are for structural support, energy storage, and cellular communication. For example, cellulose, chitin, glycogen, starch, and hyaluronic acid. Mushrooms have been used as both food and medicine since early times. Previous studies shown that Hericium erinaceus was used as herbal medicine, effective for the treatment of peptic ulcers, chronic gastritis, gastric cancer, and esophagus cancer. The methodology to prepare the sample is the Hericium erinaceus fruiting body were extracted with hexane and ethanol in cold. The mushroom's hot water crude extracts were obtained after 2 days accumulation of refluxing with the ionized water. The pulverized mushroom water crude extract were weighed. The enzymatic reaction was carried out by adding 0.5 ml enzyme solution to a 0.5 ml sample solution. A value of 0.7 ml buffer solution was added, and the reaction was observed after 1.5, 3, and 4 hours in 40 degrees Celsius water bath. The mixtures were then centrifuged at 10,000 rpm for 10 minutes. So, based from the journal, the results that we obtained is the HPLC analysis of the Hericium erinaceus hot water crude showed arabinose as the major component, with minor component of glucose, rhamnose, deoxyribose, and galactose. The absence of monosaccharides in Hericium erinaceus after dialysis indicated that all the monosaccharide content in the crude may have been passed through the membrane dialysis tube. The HPLC result revealed that most of the sugars in the crude extract have separated retention times between 3 and 6.5 minutes. As conclusion, this research shows that the fruiting body of local growth Hericium erinaceus contained polysaccharides components which were mainly arabinose.
For the next one, HPLC technique also can be applied in drug discovery and development. HPLC is known for being flexible as it can use different liquids and detectors like UV visible, fluorescence, and mass spectrometry to make testing more accurate and sensitive. It plays an important role in drug research by checking drug stability, metabolism, and effectiveness. Methodology. The HPLC method utilizes advanced equipment including pumps, injectors, and detectors like UV-Vis, fluorescence, and mass spectrometry to enable precise analysis. It incorporates effective sample preparation techniques to remove interference, optimize chromatographic condition with appropriate phases, validate method for accuracy, reliability, and applies data analysis tools to ensure consistent and accurate quantification. So this is what they have discovered in the journal. HPLC is a versatile method used for both qualitative and quantitative analysis of pharmaceuticals, including complex samples like plasma and serum. Combining HPLC with techniques like mass spectrometry and nuclear magnetic resonance enhance sensitivity and accuracy, allowing detection of trace level of drugs and their metabolites. Next, its improved packing materials and column technologies enhance separation efficiency and stability, making HPLC ideal for drug quality control, stability testing, bioavailability studies, pharmacokinetic profiling, and research in metabolomics and proteomics. Validated method in HPLC ensure accuracy, precision, and reproducibility through standardized protocols, while improve sample preparation techniques and enhance sensitivity address challenges like biological interference and trace level detection. So here is the result that they have discovered from the journal. The purpose of high-performance liquid chromatography analysis is to confirm a drug, identify, measure its quantity, and monitor disease treatment progress. Figure 1 shows a chromatogram of plasma from depressed patient 12 hours before taking dexamethasone, which is drug.
Hello everyone, my name is Rachel Anak Bakir. Today, I will talk about an important technique in science called High Performance Liquid Chromatography or HPLC, and it used in health research. HPLC is a tool that helps scientists separate, identify, and measure different substances in a mixture. In this presentation, I will look at how HPLC was used to study the stability of vitamin C in drinks like beer, wine, and orange juice. Vitamin C is a very important nutrient. It helps boost our immune system, protect us from disease caused by oxidative stress, and keep us healthy. However, vitamin C is not very stable. Its level can drop due to things like pH, temperature, and storage time. This research used HPLC to find out how to keep vitamin C stable in drinks, making the study useful for both health science and the food industry. First, let's understand how the researchers use HPLC. They use it to measure the amount of vitamin C in different drinks over time. The method was simple and reliable, and it didn't need any complicated sample preparation.
Now, let me explain the methodology used in this study. First, the researchers prepared the chemicals and solution. Fresh vitamin C solution was made every day to ensure accuracy, and a vitamin E solution was also prepared for experiments that combined the two vitamins. Next, they prepared the sample. 3 types of beers along with wine and orange juice were used for testing. Some of the samples had the pH level adjusted using phosphoric acid to study how acidity affects vitamin C stability. The sample were then stored under 2 different conditions. Some were kept at 4 degrees Celsius in a refrigerator, while others were stored at 20 degrees Celsius or room temperature. To protect the sample from light exposure, they were covered with aluminum foil. For the analysis, the researchers used high-performance liquid chromatography or HPLC. Samples were analyzed directly without needing extra preparation. Several variables were tested, including the effect of pH, storage temperature, and the addition of vitamin E. Vitamin C levels in the sample were monitored weekly over a 5-week period to observe changes. Finally, statistical methods were used to analyze the data, identifying trends, and compare the results. This methodology provided a clear and reliable way to study the stability of vitamin C under different conditions.
Here's what they discovered. The first one is effect of pH. Vitamin C stays stable in acidic conditions, especially when the pH was below 4. For example, orange juice naturally at a low pH, so it keeps its vitamin C better than beer or wine, which have higher pH levels. Secondly is effect of temperature. Storing drinks at low temperature like in a refrigerator at 4 degrees Celsius help protect vitamin C. Higher temperature cause the vitamin C to break down faster. Third is adding vitamin E. When vitamin E was added to the drinks, it worked together with vitamin C to slow down its breakdown. This combination helped improve the stability of vitamin C even at room temperature. Lastly is different drinks. Orange juice was the best at keeping its vitamin C because it already contains antioxidants. Beer and wine, however, lose the vitamin C quickly due to their composition and higher pH levels. This finding shows how important it is to control conditions like pH and temperature to keep vitamin C stable in drinks. This is not only good for health but also help make better quality products for consumers. In summary, this study shows how HPLC can be used to understand and solve real-world problems in health and food science. By measuring vitamin C levels, HPLC helps scientists find ways to protect nutrients and improve the quality of drinks. The result of this study can help the food and beverage industry make healthier and longer-lasting products. For example, orange juice can be stored in the right way to keep vitamin C content, and new fortified drinks like vitamin C enriched beer can be developed. And this is one of the examples how HPLC is a valuable tool in health research.